prove, using induction, that 1/2 plus 1/4 plus 1/8 plus up through 1 over 2 to the nth power is equal to 2 to the n minus 1 divided by 2 to the n. Alright, so let's start by showing that the trivial case is true. So let's show that s sub 1 is true. Well, s sub 1, just taking the first term on the left-hand side, that would be 1/2. And on the right-hand side, I'd have 2 to the first minus 1 over 2 to the first. And so 1/2 on the left, and on the right-hand side, I'd have 2 minus 1 over 2, which is 1/2. Alright, so that checks out. So now we will assume, so that's our first step, now assume s sub k is true. So therefore 1/2 plus 1/4 plus up through 1 over 2 to the k is equal to 2 to the k minus 1 over 2 to the k. And we will show that s sub k plus 1 follows. Alright, so s sub k plus 1 would be 1/2 plus 1/4 plus 1/8 plus 1 over 2 to the k, and then we would have the 1 over 2 to the k plus 1 term. Now, I need to show that the s sub k plus 1, I need to show that that is in fact equal to 2 to the k plus 1, subtract 1, over 2 to the k plus 1. So that's my goal. And I need to use our assumption that s sub k is true. So we can easily use the assumption by taking the first k terms. 1/2 plus 1/4 plus 1/8 plus up through 1 over 2 to the k, that is s sub k. And so since we believe s sub k to be true, we would have then 2 to the k minus 1 over 2 to the k, and then plus the other term, 1 over 2 to the k plus 1. Now we're going to add these fractions, but they don't look like the fractions we're used to working with. They have those denominators. We have 2 to the k and 2 to the k plus 1. And so I need to build them up with an appropriate factor. So what I'll remind you of is some rules for exponents. And then if we multiply numbers with the same base, we add exponents. And so what I'm going to do is multiply both numerator and denominator of the first term by 2. Because that's a 2 to the first. And so then that would give me, let's see, I'd have 2 times 2 to the k minus 2 over 2 to the k plus 1 in the denominator. And then again I have a plus 1 over 2 to the k plus 1. Now I can add these fractions together. Well, notice, wait a second, I've got a 2 times 2 to the k, and just like in the denominator earlier, that would be a 2 to the k plus 1. Minus 2 plus 1 over 2 to the k plus 1. And notice that that gives us 2 to the k plus 1 minus 1 over 2 to the k plus 1, which is our goal. We've shown that s sub k plus 1 is equal to 2 to the k plus 1 minus 1 over 2 to the k plus 1 using the assumption of s sub k. And so we've completed the proof by induction.